Hello guys, welcome to this video in which we are going to discuss about the usage of nanotubes to build thermocells in generating electricity. Diving right into the introduction, in recent years there has been growing interest in developing new and innovative methods for generating electricity. So one such method is the use of thermocells, which convert thermal energy directly into electrical energy using a temperature gradient. So thermocells are particularly attractive as a source of renewable energy because they do not rely on fossil fuels or produce greenhouse gas emissions. A promising development in the field of thermocells is the use of carbon nanotubes as a key component in the construction of these devices. So carbon nanotubes are an allotrope of carbon, which with a unique tubular structure that gives them exceptional mechanical and electrical properties. So by incorporating carbon nanotubes into the design of thermocells, researchers hope to improve the efficiency and performance of these devices. So in the literature survey, a study by he et al. In 2019 investigated the use of multi-volt carbon nanotubes in thermocells. So the study found out that incorporating the nanotubes increased the power output and efficiency of the device, and the carbon nanotubes were found to be highly stable at high temperatures. So in another study by Kim et al. In 2019 focused on the use of single-walled carbon nanotubes in thermocells. The study of demonstrated that the nanotube significantly improved the power output and the thermal stability of the device. And then a review by Cha et al. Discussed the recent developments in the use of carbon nanotubes in thermocells. So it also highlighted the potential of carbon nanotubes. So going into the study of Alcoy et al. In 2018. So carbon nanotubes are used in thermocells. So they found out that aligned nanotubes enhance the power and output and efficiency of the device and showed promises for large-scale energy production. And there are also another two researchers, one by Zo in 2018 and another by Lefanova and Bulsheva in 2021, which discussed the potential of carbon nanotubes for the use in thermoelectric applications, including thermocells. So the problem analysis for this one is it is a high cost thing. So one of the major challenges using carbon nanotubes is the in thermocells is at high cost, which makes it difficult to produce these devices at scale. Carbon nanotubes are still relatively new material, and the cost of manufacturing and processing them remains high, and also has a low efficiency, difficulty in fabrication, and also has durability issues. It also has toxicity concerns where carbon nanotubes are classified as nanomaterials and may pose health risks in particularly if they are inhaled or ingested as such. It is important to ensure that appropriate safety measures are taken by working with these materials and also some performance limitations. So the proposed solution for this would be research and development. So further research and development in the synthesis of processing of carbon nanotubes can help reduce their cost and increase their efficiency in thermocells and also improving the device efficiency. If you go like strategies such as increasing the density of carbon nanotubes, enhancing the thermal conductivity of the thermocell material, and then these properties of the device can help to improve thermocell efficiency, advanced fabrication techniques, and improving durability and health and safety is developing best practices for the safe handling and disposal of carbon nanotubes can help to mitigate against the potential health and safety risks associated with their use, and also applications and market development, which plays a prominent role in new applications for carbon nanotube based on thermal cells. Like exploring new markets can help to drive down the cost and increase the sale of the production. And then the methodology for this would be synthesis of carbon nanotubes. So the first step in the building of a carbon nanotube based thermocell is to synthesize the carbon nanotubes themselves. So this can be achieved by using a variety of methods such as chemical vapor deposition or arc discharge and laser ablation method. So characterization of nanotube properties. Once the carbon nanotubes have been synthesized, their properties must be characterized. This can include measuring their electrical and thermal conductivity as well as thermoelectric properties to determine the suitability for use in a thermocell. and then fabrication of thermocell structure, and then optimizing the device properties and evaluation of device performance. I mean, once the carbon nanotube based on the thermocell has been fabricated and optimized, its performance must be evaluated. This can include measuring its power output, efficiency, durability under different operating conditions. So scaling up production is the final thing we have to do, final method we have here. So if the device proves successful, efforts can be made to scale up production and explore new applications for the technology. So the resources and techniques is a new topic in which the first point would be carbon nanotube synthesis. There are many methods for synthesizing carbon nanotubes, as we discussed earlier, or the chemical vapor deposition, or laser ablation, or the arc discharge. So there is these techniques require specialized equipment and expertise in material synthesis, and then characterization techniques, and then to evaluate the properties of carbon nanotubes. These techniques such as Raman spectroscopy, scanning electron microscopy, transmission electron microscopy can be used. So then thermocell fabrication techniques such as chemical vapor deposition or inkjet printing can be used to fabricate thermocells. Optimization techniques such as optimizing the geometry and dimensions of the device and exploring different materials and configurations can be used. And at last, performance evaluation techniques to evaluate the performance of the carbon nanotube thermocells. Techniques such as electrical measurements, calorimetry, and thermography can be used. So these techniques can provide information on the device's power output, efficiency, and also durability. So coming to the final part, coming to the uses, the main part, uses of nanotubes. I'm very sorry for that. And then it is used for high power density. So nanotube based on the thermal cells have potential to generate high power density due to the high electrical conductivity of the nanotubes. This makes them suitable for applications where high power output is required, such as in spacecraft power systems. The efficiency of thermocells having the potential of high efficient as they can generate electricity from waste heat that would otherwise be lost. This could lead to the significant energy savings in industrial and commercial settings. So scalability, the use of nanotubes in thermocell devices could allow easy scalability, as carbon nanotubes can be synthesized in large quantities and integrated into various device geometries. Durability and sustainability. Carbon nanotubes are known for their high strength and resilience, so which would make their thermocells made with nanotubes more durable than conventional thermoelectric materials. So sustainability, when it comes to sustainability, the use of thermocells can reduce the waste and increase energy efficiency, contributing to more sustainable energies infrastructure. The validation would be experimental testing, such as this involves building and testing prototypes of the thermocells, measuring their electrical output under different operating conditions and comparing their performance to the thermocell designs. And then computational modeling, efficiency analysis. Inefficiency analysis can be used to validate the energy conversion efficiency of nanotube based thermocells. This involves calculating the electrical output of the thermocell as a function of the temperature between the hot and the cold ends and comparing this to a theoretical maximum efficiency for the given materials and operating conditions. And then comparison to other technologies, comparison to other thermocell designs and an alternative technology for generating electricity can help to validate the effectiveness and potential advantages of nanotube based thermocells. And then finally we discuss about scaling up. Scaling up is the technology to a larger system, and testing it in the real world conditions can help to validate its effectiveness and potential for commercialization. So this involves building larger scale prototypes of thermocell and testing them in a range of environments to demonstrate their reliability and efficiency. In conclusion, the use of nanotubes to build thermocells shows premise and potential solution for generating electricity from waste heat. Nanotubes possess unique thermoelectric properties that allow them to convert heat energy into electrical energy, making them an attractive candidate of thermocell designs. Furthermore, nanotubes are lightweight, flexible, highly conductive, which makes them ideal for use in thermocells. However, Further research and development are necessary to fully realize the potential of this technology. Validation studies involving experimental testing, computational modeling, efficiency analysis, comparison to other technologies, and scaling up will be necessary to determine the feasibility, effectiveness, and the potential advantages of nanotube based thermosels. In addition to this, cost considerations and manufacturing challenges will need to be addressed in order to make this technology commercially viable. So the references we took to make this presentation are here as well as you can go through them if you are interested more in this. Thank you for watching this video.